The moment of truth has arrived. Pray for me.
You look like a little steamship.
It's time to install the electrical system in the workshop. We're going to install 7 outlets, some of 10 amps and others of 16 amps to connect the more powerful machines. We are also going to install a panel. For that, we have a 16 amp circuit breaker along with a 25 amp residual current device. Later on, we are going to bring in an edge bander and a planer, which are more powerful and need a bit more automation. In this case, we are going to use a 20 amp circuit breaker and its 25 amp residual current device. We are using a cable thickness of 2.5 millimeters, which will be more than enough for the use we're going to give it here in the workshop when I bring in the edge bander. I would like to be able to make the connection with a slightly thicker cable, 4 millimeters, but for now we'll only use the outlets from the 16 amp circuit so that 2.5 millimeter cable will be perfect. I want to mention that I'm nowhere near an expert in electricity. If you want to learn how to install an electrical panel, I recommend you look for other videos on YouTube, because there are experts and more professional people who teach how to do it. The idea is that if we go over the 16 amp limit and we're using tools or consuming a lot of electricity, to prevent those 2.5 millimeter cables from heating up or eventually getting damaged, melting, or causing a fire. This switch will trip first, so our protection is our guarantee. The idea is that the switch trips before the cables heat up. For 2.5 cables, 16 amps is perfect. And the differential is to protect us. If we get an electric shock, this will trip immediately. Very important, since it can save our lives. If you want to know how many we can use with a 16 amp thermomagnetic switch, you have to multiply the amps by the voltage. Here in Chile, we use 220 volts, so we multiply 16 by 220, which gives us 3,520. That means we can use a machine that has up to 3,520 watts. This table saw, for example, the one you probably already know, uses 1,800, I think 1,800 or 2,200 in the English one now. That I have here uses 1,800. So in theory, it would be really tight if I use both at the same time. Do I have to use one or the other? If I go over those 3,500 watts that this switch allows me, it should automatically shut off. Yes, we're going to connect the ground wire to this terminal. This ground wire comes from the main panel of the house, which in turn is connected to a copper bar that goes directly into the ground. We are putting these terminals on all the connections here on the panel. I think it's going to be much better with this same wire stripper that has a small press here to do this. Our ground wire, which comes from the main panel, is always the green wire, at least here in Chile. The white is neutral and the red is the live wire, meaning this is the one that carries the electricity. In any case, I recommend that you always check with a multimeter or a voltage tester which of the wires is the live one, since not everyone respects the color codes when doing electrical installations. So the sure way to know is with a voltage tester or a multimeter. Now let's install our switch, thermal magnetic breaker, and our residual current device. The circuit breakers in the house are off. There's no electricity in this outlet circuit, so we can work safely. Here, we continue the phase from the thermal magnetic breaker. Down here, there are outlets below. Then we run it back here so everything stays organized and we put the phase back in. At this point of the differential, you have to check, because each differential is marked to show where the phase goes and where the neutral goes. This particular model has the phase on the left side. Now the white wire, the neutral, we put it through here. So we have the phase, it goes through the thermomagnetic switch, goes down here, loops around, goes into the differential, and after the differential it comes out here. The phase. directly to the circuit of the wires, of the outlets, sorry. And then the neutral simply enters through the differential, comes out of the differential, and connects to the outlet circuit. The ground comes from the house and connects directly to this terminal that has the ground symbol on it. And then we take another ground from here, from the screw next to it, and it joins with these two that already came out of the breaker, the phase, the neutral, and the ground. And from there, we're going to connect throughout the whole workshop. We're going to use these metal conduits called electrical metallic tubing, and they're going to run on the outside. We're going to do all the external wiring throughout the workshop, which I think is much more practical in case we need to repair something.
To the connection.
All the conduits are already installed with their respective boxes, and now we have to run the cables. We're going to use this fish tape. We're going to insert it through here, through that hole, and we're going to do the whole route first with this fish tape. And once we reach the end, we're going to connect the cables from here and pull them through so they go all the way. I'll show you now so it's clearer.
Yes.
We help the tip of our cable puller through and keep pushing. With so many bends, some resistance is already building up. So what I do is start pushing from here and here. After these two bends, we'll reach the outlet and it will be easy from there. Now that we have the fish tape through the whole circuit, we need to tie the wires here to this end and then pull from over there. We're going to lubricate this a bit with a mixture of beeswax and petroleum jelly. You can use soap or whatever you have, so this can go through more easily. To connect this double outlet, we're not going to use a jumper. We're going to connect them in parallel. What does it mean to use a jumper? Basically, it's connecting each of these wires to one of these holes, phase, ground, and neutral, and then using a short wire to make a bridge over there. 1, 2, and 3. The problem with using a jumper is that if we're using both outlets at the same time, the outlet where the jumpers come from can overheat, since it receives the load from both outlets. The best thing for my case is to make a parallel connection. That is, strip these 3 wires here, run a wire over here, and then from this same point, run another wire over here. So there will be 3 jumpers, 3 here and 3 over there. When it's ready, I'll show you. So it's going to be phase, ground, neutral. That's the recommended parallel connection if you're going to use both outlets at the same time. We already have the connection ready, so the cables coming from the house come through this hole here. We put the ground wire through here and attached it to the first screw on the terminal. Then the phase, which is the red one, goes up here through the breaker, through the thermomagnetic switch. Then that phase comes out from below. We turn it around and it goes up on top to the differential on the phase side. Then the neutral that comes from the house goes directly into the differential here and comes out over here. Two outputs from the phase and the neutral of the differential go straight directly through our conduit, along with the ground, this second ground, which also goes with the phase and the neutral, and goes around to all the outlets. Let's test the outlet. I'll try them all and let you know how it goes. Well, friends, with this I say goodbye. That's it. The work in the workshop is done for today. I have to go back to Santiago now, but I'll be back soon so we can keep making videos. Here, in this new home, we're going to have to make furniture for the tools, lots of drawers to organize to get ourselves sorted. So it's going to be good, fun things are coming. Sending you all a hug. Take care, and I'll see you soon in the next video. Bye-bye.